All right, good morning everybody. Welcome to this talk on Dapr in practice. First, maybe a show of hands, how many of you are familiar with Dapr beforehand? Quite a lot of you, that's great. My name is Marc Klefter. My LinkedIn bio currently says that I'm helping organizations become event-driven. What does that mean? Basically, I support cloud-native application development efforts with a special emphasis on event-driven principles, patterns, and best practices, which also happens to be the context where Dapr comes into play. So Dapr, as many of you, I guess, then already know, stands for Distributed Application Runtime. It's an open source CNCF project aimed at, as the name implies, developing distributed applications. So while this is a very interesting technology, and yes, I'm biased, the talk is named Dapr in practice for a reason. So yes, we will be exploring Dapr to a large extent in this talk, but I also want to focus specifically on the practical considerations should you also find it interesting and maybe want to adopt it, because there are a lot of moving parts here that you should be aware of in that case. So let's start by setting the stage a little bit for our exploration of Dapr and the practical considerations. So what do we mean by a distributed application? We'll use the popular term loosely coupled. Application services that are distinct processes that communicate synchronously and or asynchronously. And for the purpose of this talk, we'll assume a cloud-native environment where we package, deploy, and run our application services as containers. The platform of choice will be Kubernetes, which is a good assumption because Dapr is deployed currently upwards of 90% in Kubernetes. So yes, you can run Dapr in other environments, on-prem, virtual machines, even serverless, I believe now. But we'll stick with Kubernetes for now. And as an application, you utilize a number of capabilities that are common, so to say. Some capabilities are provided by a platform. So in Kubernetes, you rely on it to provide you with service discovery, scale out, and so forth. Other capabilities are more cross-cutting, not provided by the platform. They relate to security, observability, resiliency, and so forth. Sometimes you can see them offered by a service mesh, for example. And then you have capabilities that the application directly uses or relies on to implement domain logic. So we're talking messaging, state management, workflow, etc. All these capabilities are needed, of course, to have a well-running application. So we'll, in Dapr, focus on the two latter parts, the cross-cutting concerns and the capabilities that you will find offered by a cloud provider such as AWS for messaging, state management, and so forth. So these capabilities, you can think of them as patterns for services or microservices. And in this book, which I highly recommend, it's a couple of years old, but still a very good read. It summarizes all of these capabilities in a neat format, again, as they relate to communication, state, and workflow. So let's look at messaging first as a capability your cloud-native application might have to utilize, utilizing a specific vendor's offering. So here you see a Node.js app deployed again in Kubernetes that has to publish certain messages to a SNS topic. So directly in our application code, we are relying on a dependency that we have declared that we need, and we've also downloaded the AWS SDK for JavaScript, specifically the client SNS module. And we are instantiating it, we are configuring the SNS client, and then using the API provided, publishing a message to a certain topic. This we have to do for all services that need to publish messages. And the corollary, you'll have to utilize the subscriber part if you want to consume a message that has been published. And again, all of these services are independently deployed, developed and deployed, so they all have to factor in this dependency in their application code. There are a number of issues when you pursue this mode of integrating directly with, in this case, AWS SNS. The first one is that you have to, as you saw, specify a version of your client library or a driver. So you have to make sure that the SDK you are using matches the resource or cloud vendor service and the functionality currently offered. And this has to be ensured for every application service that utilizes this. So you have a matching issue you need to be aware of. It goes without saying that you are by default tied to a certain infrastructure, in this case SNS and SQS. You're using a vendor library with all of that custom configuration, resiliency policies that are hidden or present in the SDK that you might to some extent configure. And you also have to, of course, be aware of security aspects, such as having the necessary credentials to publish a message, which might differ depending if you're running something locally for testing or actually in production. And you have to set a number of access control policies, so you have to know AWS, IAM, etc. So that's a lot of things that we as application developers have to be aware of, not only how we implement this in code, but also all these settings and dependencies. Is that what we actually care about, or are we looking for something simpler perhaps? I would argue that this is what we are basically looking for. I want to publish a message to a certain topic. If I can only care about that part, my developer life will be happier. And so this is where you see Dapr entering the scene by providing the necessary building blocks, as we'll see, for example, accomplishing messaging in a simpler way. So let's look at the Dapr first as an overview. Many of you might have seen this beforehand. So you have your application code. We just saw Node.js example. And you interface with the actual runtime, the Dapr runtime, which is its own process. You'll see it's a sidecar shortly. And there are two ways to interface with this sidecar or runtime, through HTTP or gRPC. HTTP is the most common, I believe. And inside of that runtime, you'll find a number of building blocks that you can utilize. So going left to right, you have a building block for service invocation. So in contrast to directly creating a URL and invoking some service, you will be utilizing an intermediary service invocation here to accomplish that. You have a building block for state management, should you utilize a key value store for session information or what have you. Publish, subscribe, messaging, as we just saw, very popular building block for that purpose. You have input and output bindings if you want to communicate with external systems. I call it the great escape hatch, as we'll also see shortly. And more specific building blocks, perhaps, like distributed locks, secrets configuration are important. You'll have to get settings into your app somehow, and this is a standardized way of doing that. And then you see those cross-cutting concerns underneath the building blocks that will apply across your services that might utilize these building blocks. Again, observability, security, access control policies, resiliency policies, and so forth. And it says you can run this on any cloud or infrastructure, basically. Again, we're focusing on a Kubernetes environment for now. So these building blocks, they map pretty well with certain microservices patterns. And on this slide, it might be a little bit hard to see, but this is taken from a web page, microservices.io. And in this article that you see referenced, they have also applied a little hat, the Dapr hat, on top of the patterns that these building blocks actually support. So for example, you see transactional messaging. That's the pub sub building block. You have the outbox pattern, also supported by Dapr now. Certain things that go along with that, health checks, circuit breakers. So a number of these patterns are featured and supported by Dapr. Some are not. One of those is, for example, event sourcing. We'll be looking at that specifically later also. So you can have this map, and you can then one-to-one basically move to Dapr and see if what you need is actually supported. That becomes important for your eventual choice of adopting Dapr. Are enough patterns that I need present in Dapr for me to utilize? So these are building blocks, but they are just that. Basically, they're APIs. So the Dapr community, if you will, have standardized a certain set of building blocks. They describe the API, how you communicate with this building block or instances of it, certain semantics. So for pub sub, you're guaranteed at least once delivery. You're using the cloud events message format. Message routing happens in a certain way, content-based, etc. So you get an API and certain semantics guaranteed if you use the pub sub building block. But the actual implementation of a building block is done by a component. So that's the interface is as a building block, and the component is the implementation. And that can be for any type of cloud vendor or utilizing any type of cloud vendor services that adhere to the building block specification. So as the example we just saw, we utilized SNS and SQS. There happens to be an implementation, a component for pub sub with SNS and SQS. So we can just use that component, tell Dapr that's what we intend to use. Our application code will transparently then interface with that. And there are a number of components that you can choose from depending on your circumstances. If you look at Dapr in a little bit more detail, again, I mentioned sidecar. So in your pod, you will have your application container running along the Dapr sidecar. You will have something of a control plane in your Kubernetes cluster that makes sure that each sidecar behaves appropriately and can function as you intend it to do. And you annotate, as you usually do, that you want your sidecar injected. And once that has happened, the sidecar will get requests from your applications, publishing a message, for example, and it will then, through a specific component that you also specify, make sure that it is published accordingly. I should also mention that components by default are built into the Dapr binary. So the communication between the sidecar and the component actually occurs in the same process. Sometimes that's not enough for our purposes. So there are pluggable components that you can also implement. We'll get to that as well. Again, this is happening within one cluster. So that's our frame of reference for this discussion. If you want to manage this beyond kubectl, you probably will have to use something like Conductor. So there's a commercial entity backing Dapr called Digrid, and they offer a management tool for your Dapr-enabled clusters called Conductor. It's highly advisable that should you pursue Dapr in your project, that is something to look into, because managing it manually can become quite overwhelming, which is also one aspect to consider specifically if you want to embrace Dapr. How do you actually manage this control plane? Let's go back to the example we just saw and see if we were to move away from direct integration with AWS, SNS, what would the Dapr equivalent look like? So to the right, you see our application code, now rewritten with Dapr. So we are using the Dapr SDK, we could just as well have used direct HTTP call. That's how we interface with the sidecar. And in this application code version, you will see that we're simply publishing to a component, a pub subcomponent, a specific one, the details of which are on the left, to a certain topic with our data. That's it. That's sort of the abstraction we were looking for, and that's what we also have right now. You see the actual REST call to the sidecar underneath. To the left is the component. We're using the pub sub building block, but this component is what actually makes things happen, what actually publishes the message on our behalf to SNS. And this you can apply as any other metadata to your Kubernetes cluster. So you see some of the details that previously were featured in our code, now extracted into a YAML file, such as the region. And you can add more settings here, of course, that are specific to SNS. Noteworthy in this case is the publishing scopes part. So you can now specify access control policies between your service and your component, and in this case, telling Dapr explicitly that this particular application service called payment processor is allowed to publish, but only to certain topics. So you have a new layer, so to speak, of access control you can utilize that is fully decoupled from what happens in AWS. Yes, you need to set up things there as well, but that's the component job. And there is hopefully a platform team that will help you with setting up and actually executing this YAML for you. We'll get to the provisioning part of Dapr at the end of this talk. But inside of your application, your services, you can now reason about what can access what. This service can access this component and specifically publish to a certain topic. This is highly useful if you want to control the interactions between your services and components. I should also say that in this case, your SNS topic in your queues will be automatically created for you in AWS. This is not recommended behavior. Your actual resources on AWS should be created separately. You have to apply this component. This has to be applied in your cluster, but that is also decoupled from the actual resources you will use. Again, as developers, we want to go away from all these concerns and just focus on the piece to the right, our application code. So there are platform considerations that we need to look at as well to make the component YAML and actual topics and queues being created on AWS handled, hopefully for us. So this was messaging. Of course, service invocation is a very popular building block for good reason. So you might have two application services, one handling customers, one handling checkout. Customer wants to call checkout to perform checkout. So you would, again, call that checkout service through a name, an application ID, which is checkout. So you're not, again, constructing a URL as you would normally do to invoke a remote service. You're using this form of indirection through a service name or application identifier, in this case checkout, to reach or instruct Dapr where you want your request to go. Dapr will utilize the type of service discovery mechanism that it supports or can find. In this case, it will be kubedns. It will invoke the remote sidecar, which handles the checkout service. You can then apply encryption if you want to, and MTLS. And the checkout will then receive the request on a specific route /order. And if you want to, of course, you can automatically generate traces and get metrics in this flow. So the important part is you get a number of features as part of this building block package that you can utilize. But the important part is you have a level of indirection through an application identifier, in this case checkout, that you use when you want to interact with that particular service. Now, some of you might be wondering, what's the difference between Dapr and service meshes? Do they overlap? Do they this seems like a service mesh would also provide a similar level of functionality. And you would be right. There is an overlap. Now, Dapr is not a service mesh. If you think of a service mesh, that is something that is typically completely transparent to you as a developer. You don't see those things happening on the side mesh, the service mesh level in your code, etc. So that's on a network or even infrastructure level. But in Dapr, you're explicitly using building blocks like service invocation. And that's sort of the scope of Dapr as far as service mesh goes. So, for example, in a service mesh like Istio, you get a trace when one service calls another synchronously, say, but it doesn't support pub/sub. But on the Dapr level, if you call a service and that service in turn publishes a message, you can trace all of that. So you have a more of a workflow level kind of trace that is not possible with a standard service mesh. So could these work together? Yes, they can. Sometimes you have a service mesh with policies for traffic control and splitting that applies to all traffic in your cluster. Then you have, of course, and that might also include MTLS already enabled. Then you would simply turn it off in your Dapr runtime. So these can work together. Personally, I have not come across a project myself that has both, but it's fully possible. But there are some practical issues just to be aware of, so you're not enabling the same functionality on both levels. So if we take all of these pieces together and see what we actually get out of it, we might say that we now have an enabler for true application portability. Not my term, but it's a useful one. So we already have portability for compute, right? We have a standard way of packaging our application services and deploying them on Kubernetes. You can more or less take the same package and deploy it in another cluster, in another cloud vendor. That's not been the case, again, as we saw with application code, directly integrating with, again, SNS, for say. But with Dapr, we also get portability on our application level. So both compute and integration with various services, without which we cannot really achieve full portability. Another interesting facet is that often there are switching costs incurred, implied, when you try to build out an architecture or migrate from one system to a more modern one. So for example, if you are sort of extracted from what product and version of a particular service you're using, as we saw that Dapr enables, that is a minimizer of that cost. Speaking again from the level of application, or from the perspective of application developer. Again, if you build out an architecture with common building blocks, maybe you don't have to reinvent the wheel all the time. You can go to these building blocks. You can retain your knowledge of them, apply them again and again, hopefully. Policies, if you write your policies for resiliency and access control with Dapr, you can, again, build new applications or modernize existing ones using the same principles. Your skills are hopefully long-lived in this case. You don't have to learn new APIs that are vendor-specific. And you can also achieve compliance like auditability in a standard way that's sometimes hard to achieve with, again, vendor-specific alternatives. Most importantly, you don't have to adopt everything in Dapr at once. These building blocks are called blocks for a reason. You can choose the block that makes sense to you in your current project or as it evolves into the future. So again, if you take a situation where you have a monolith today and you want to apply the strangler pattern to bit by bit extract pieces of it that become application services, you can neatly adopt Dapr block by block in those newly built services as you see fit. Again, you have to enable Dapr in your Kubernetes cluster, but beyond that, as an application developer, you have a lot of leeway in terms of what makes sense for you in terms of building blocks to build out your your business logic. This might sound a little bit abstract, so let's go to a concrete example of where you would start as a developer building out a system. As is good practice, you should always, not always, but it's very good practice to model your domain. I am a huge proponent of something called event modeling, which describes how your system changes state over time. And you have 3 stickies that you can use to describe a flow in your system. Commands express intent to change the state of your system. The yellow stickies, events, describe a state transition, and the green stickies are what's termed read models, where you can actually read state. As you can see, this flow neatly divides into vertical slices. And for each slice, we can align Dapr building blocks if we want to start to reason about architecture, system architecture. So let's quickly go through each slice and see how Dapr supports them when we go on to implementing them later. So for the first slice, when we request a bike, and not pictured here is the building block of an API gateway, etc. So that is just implied. The building block we will be using is first service invocation, because the lane that says bike management will probably become its own application service. So from our API backend, we'll need to call in a Dapr way this service. That's why this building block is there. And we'll also have to update state. So if someone requests a bike, we need to store that information somewhere. So a state management building block is necessary. The second and third slices, well, something needs to select a bike for us, run some algorithm based on some data. It needs to read state. In the first case, again, we're using the state management building block to read state. In the third slice, you can see that we're combining state management with pub/sub to accomplish an outbox. So a bike request is stored, a message is also atomically published to the selector to make it aware of that event. So given this information, the selector can choose a bike for us. Again, it will utilize service invocation, pub/sub, to trigger a workflow. This is exciting because Dapr workflow, I don't usually like the word game changer, but it's a pretty big deal, as we'll see. So we'll start a workflow. So we'll use a Dapr workflow building block for that. And we'll also utilize bindings because we need to communicate to the station where the bike is at that it needs to unlock it. So we'll use an output binding, that building block in Dapr, to make sure that the station receives a command from us to unlock the bike. We'll start a timer, 60 seconds for me to pick up the bike. And should I pick up the bike, again, the workflow needs to involve service invocation, state management to update that there's one last bike available at the station for the next customer. And there the workflow also ends. So I like this because I can model my domain and then I can per slice see what building blocks that I need. Again, some are implied like API backend or gateway. But if you just look at the Dapr ones, it gives everyone a quick look at what will be required. So to me, the workflow part is particularly interesting because it gives us a portable way to describe workflows. That was one of the patterns that we saw earlier. Then it was called sagas. But again, we're trying to describe larger flows or workflows, and Dapr offers that for us. So you can describe in code the type of workflow you desire. We'll see an example of it on the next slide. You can make it durable, where it functions durably. So should your workflow for some reason crash, you can resume it and then continue on. You can use a number of languages to author your workflow quite seamlessly. And there are sort of common patterns, workflow patterns built in that you can simply or easily write. So if you're going to use this workflow engine to implement the unlocking of the bike and the timer, how would that look like? So in Dapr, you can use this waiting for an event pattern. So we're starting the workflow by notifying the customer or the renter through an output binding that you need to unlock the bike, or the bike is now unlocked. At hopefully some point, the renter will pick up the bike. So this workflow will receive an external event from an input binding, also a building block in Dapr, and we'll then be able to update our state with the number of available bikes. However, if I don't pick up the bike within 60 seconds, for which we have a durable timer, the Dapr workflow will then lock the bike, again telling the station through an output binding that you need to lock the bike again. So that's the high-level flow on the left. The workflow actually utilizes basic building blocks in Dapr to accomplish an overall flow. And hopefully you can see that the code to write this is not that difficult. It's quite straightforward. Your actual activities where you use, for example, an output binding to unlock the bike, you have them sort of invoked in the call activity method. So the chart as transformed into code is more or less one-to-one. Hopefully you agree with that assessment. Again, this is one of the major selling points, at least for me, when it comes to Dapr. I don't have to rely on external other workflow engines to accomplish this. This sort of follows on the application portability theme that I like. Now, not everything, of course, is provided by Dapr for you. There will be things that it doesn't support. And from recent projects, the thing that I've needed to work with that Dapr doesn't support is event stores for event sourcing. So those who are unfamiliar with the term, an event store stores business events natively. So much like you publish events using PubSub, you can store events as a single source of truth for your application. Again, there are specialized stores, event stores for this purpose, and that is something I have had a reason for using in a number of projects. However, there is no support for it in Dapr. What are our options? One is we wait for a new building block. But again, that's kind of a hard thing to drive through. You need to engage the community, get an agreement on it, and then you have to make sure it gets part of the official specification. Hard sell. If I'm not the only one wanting it, but again, it's not something we can wait for. So this is where I mentioned, again, input and output bindings as our escape hatch. We can use bindings to interface with any type of external system, including event stores. And again, components are actually built into the Dapr binary. But we can't fork the Dapr binary and include our component. That's also quite tricky. Instead, we can build it as a pluggable component. We can run the component as a separate process and then tell Dapr that I now exist. You can use me to interface with an event store. And the application developer will use bindings to do that. Let's look at an example, again, building on this bike rental example. So here, I need to actually store the yellow stickies, my events. This will be the source of truth for all my state in my application. How do I do that? I can use an output binding to interface with an event store. I'm using the Axonic technology stack for this purpose, and this binding will have, as any other building block, a component that knows how to speak to Axon Server, the event store. You cannot do it directly, so there's a add-on called Axon Synapse that you can use to accomplish this. So what happens? I send out a command, basically a message, through this output binding to Axon Synapse. The binding has a component, an actual implementation that knows how to speak to Axon Synapse. Again, that's hidden from me as an application developer. And then it will interface with the actual event store to process the command, yield an event that is stored in the event store, and also update the number of available bikes. Again, if you're familiar with CQRS, perhaps, you'll find some recognition here, I hope. The details of which are not that essential for this discussion, but just that we are using output bindings, a building block in Dapr, with a specific component that either we or someone else has developed to interface with the event store. So this component, what will it actually look like? Well, in our code, we'll simply say, send a command, send a message that we want to change state, that we want to generate an event. We'll target the component, we call it message bus. The operation is something we can define, or someone who builds this component can define for us, that we can invoke. And then we'll tag along the actual message, the data in the release by command. The Dapr sidecar and the component will communicate performantly through gRPC, and then the component handles all the tricky stuff by interfacing with the event store. But again, there are a number of operations defined on the component that we can utilize, and we can apply this YAML to Kubernetes, to our cluster, to make sure that it starts existing, starts running, so we can invoke it from our code. Hopefully you're seeing that adopting Dapr, where there isn't a building block available for you, can be tricky. I'm not showing this to scare you off, just to be mindful that should you encounter a case like this, there are a few steps you need to be aware of to make all of this work. It's not too much work, but it's something you have to be mindful of. There's another interesting aspect when it comes to Dapr. And that is the fact that Dapr, by its very notion, is working distributedly, or in distributed fashion, aka everything goes out on the network. Not everything has to go out on the network in our code. If you're building an application that is largely or completely message-driven, like we saw with commands, queries, and events, you're relying on something called location transparency. You're sending out, say, a command, an instruction to another service that you want to change state over there. By using a command, a message, you're not aware of what the target destination is or where it is. It might be in the same process, it might cross a network boundary to get there. But in Dapr, you're actually always communicating at least your sidecar and beyond. That might be not the most optimal way should your service that you want to reach actually reside in the same process. Why is location transparency good? You can start by building a modular monolith that communicates through messaging. When the time comes and you need to extract components, you can do that completely transparently, because messaging allows you to do that. You don't know where your message is routed to, and that's the whole point. So there's a lot of benefits utilizing this characteristic of location transparency, but Dapr doesn't sort of allow for it from the get-go. You need to build some abstraction to support it. So again, distributed application runtime, awesome, but it's not always what we want by default. So you might encounter the need to create certain abstractions. So for example, when I send a command, using the event store example from earlier, sometimes the command handler, the thing that actually processes my command and generates an event, is in the same process. So I will need some abstraction, call it command bus, that knows about the destination for my command and says, okay, this one is in the same process, so I will skip sending something out onto the output binding. But if it actually needs to traverse a network boundary, I will route your command over the output binding to the event store and a remote command handler. Again, Dapr doesn't come with this. This is application specific. You will have to build something along those lines if you want to take advantage of this location transparency characteristic, which I hope you will if you build a message-driven system. Again, all to say, Dapr gives you a lot of things that you can utilize to build your domain logic, but there are some cases where you need to add additional abstraction on top. This is one way of extending Dapr for your purposes. Sometimes it's not as involved as what we just saw. So you'll more likely than not encounter the case where, yes, you're using a Dapr building block, in this case state management, to store state and read state, maybe in a SQL database. But you also maybe want to run some efficient SQL query directly onto the database. There is no SQL building block in Dapr. I'm not sure there needs to be, but if you still need to run a query against your database, where do you put it? How do you accomplish it? Well, we try to isolate things, as we normally maybe do. So while you might be storing state, key values, pairs using the Dapr building block, you can isolate your direct queries into a separate service. And from a service A, you can use Dapr service invocation to call service B, where the actual raw SQL query is executed. This is actually how you would typically also utilize Dapr in a brownfield scenario. You would isolate sort of the details in a separate service. And here you have the same problem that we started with, a specific driver matching a specific version of Postgres. But at least you can minimize the, what do you call it, blast radius should something happen. You can isolate that part into a separate service, while the rest of your application is oriented more or less fully towards Dapr. So that's a valid strategy to employ if you happen upon a scenario like this. Why isn't SQL a building block in Dapr? It's not a pattern. It's not a microservice pattern that you could find in the map we saw earlier. SQL is just an interface to, well, SQL databases. It's a language. So it's not naturally something that would become a Dapr building block. Not to say that there might be other aspects to it that would make it a building block, but I'll see what the future holds in that regard. Again, extending Dapr, these types of dependencies, there's another consideration that every type of abstraction layer brings with it. Your abstraction layer, your logical layer, if you will, you cannot abstract away what goes on underneath, the physical properties. A quote from a famous architect. What does that mean? You will more or less become aware of things like pricing, scaling, error handling, geographical availability that your abstraction layer relies on when it comes to the Dapr components, for example. So, simple example. Let's say I wanted to employ state management in Dapr, and there is a Postgres database already available that I can use to store and read state. However, in my case, it turned out we needed a RDS proxy. We needed a proxy to multiplex database connections to the database because it would become unwieldy otherwise. However, the RDS proxy at the time was not available in the EU North 1, Stockholm region. So yes, I wanted to use Dapr. I wanted the component that supports Postgres, but I couldn't really use it because the proxy, the technical detail, was simply not available at the time. So the abstraction layer was supposed to give me state management, but in reality it was hard to actually accomplish using the Postgres component. There are other differences when it comes to pub/sub, like SNS and SQS. In SQS, you have the notion of visibility timeouts. If you consume a message, you want to hide it from other consumers while you're processing it. Not every queuing system has this notion. So what do you do with a building block that apparently supports it for everything? Well, you get in the nitty-gritty details, you realize you have to adapt the component settings and a lot of that stuff to make sure that the promise of the pub/sub holds true. Again, the abstraction layer sounds good in theory, and it is good in almost all times in practice, but you will encounter some physical characteristics that you cannot escape. And that's the trade-off. You're raising your level of abstraction or operating there, but it also makes you compromise sometimes on vital technical issues. I want to end with what we alluded to earlier, and that's platform engineering and how it relates to Dapr. Now, we've seen that we're essentially decoupling platform infrastructure aspects from our application code to Dapr. But things don't just create or get created by themselves somewhere in your cloud vendor. Something has to provision resources that your application code will rely on or invoke. So what do we do with provisioning? So let's say that I want to use state management again, and we need to deploy a database for this, the Postgres. And there will be a component that makes sure that Dapr and my code gets linked to this specific database instance. There is a tool that is quite popular called Crossplane. You might have heard of that as well, where you can create abstractions, platform abstractions, for what we in our team might call or mean by a database. So in this case, there can be an abstraction. We can select that we're wanting to provision this on cloud, in a cloud setting, AWS specifically, and the database instance should be small, whatever that means. And we can apply this, and Crossplane will then reach out and provision the associated resources in this abstraction for us in AWS. Quite handy. But that only deploys the database. We need to still connect it to our code through a component. How do we do that? Well, I apply the database abstraction to my cluster. Crossplane sees that. It instantiates sort of this concrete database by provisioning it on AWS. It will create the necessary credentials, store it in Kubernetes secrets, and it will also apply this Dapr component that needs to be applied for the sidecar to interact with. So the yellow parts will be automatically created by Crossplane, and then my application can simply use Dapr through the component to store state in Postgres. Again, this is not, something that Dapr provides. We need to create this scheme ourselves. But there are a few things that are non-trivial. So naming our services, application identifiers, who decides what my service is called? Is that us as application developers, platform team, us together? Security policies. Am I in my app allowed to actually use the Dapr component to store state? We saw previously that we can use Dapr to control access between services and components. Who decides on those policies? So this is more of a managerial issue maybe, but it's hugely important to have something where you can easily negotiate and then actually create these abstractions to arrive at a solution like this. Dapr and Crossplane by itself is quite low level. Again, this scheme is low level. As application developers, we would maybe like something like this. We would say that I want an environment locally, in a staging or in production. I'll have an application to deploy, and I have a database that I need. Specifically, you need to instantiate or provision this database, but I also want to use it through Dapr, so you need to apply this component for me as well. This is using a solution called Cradix, which is quite interesting, because it gives us sort of that, I wouldn't say final, but it's a vital piece of the puzzle. So if I can combine my application considerations with the infrastructure I need, with Dapr components also mixed into it, and that is all I apply in a GitOps fashion, well, I would have arrived at a pretty good solution for myself. So again, just embracing Dapr is not a thing. You will have to deal with these issues as well, and they can be quite large in scope. Several teams will have to negotiate to arrive at something like what you see on the slide. This has been quite technical in a sense. I want to end finally with what our developer actually saying about Dapr. So I've been saying a lot. What are people out in the field telling us about Dapr? This is from a survey from last year. We start with the type of building blocks. Well, these are the building blocks you would envision would be the most popular. PubSub. Everybody needs PubSub. Who doesn't? So that goes without saying, perhaps. But then closely followed by service invocation. You need this type of indirection that building block provides to apply various types of policies, etc. So, yeah, and state management as well. These are the top three. They're always what developers that utilize Dapr voice to me as well. But on a grander scheme, what do they actually like about Dapr? There's one that has surprised me. That says no code changes when swapping components. That's a great promise. That's actually something you can achieve with Dapr. However, is that actually something that happens often? That you actually have taken advantage of, or is it a nice to have? The survey didn't say. I personally find it hard to believe that they have actually utilized that feature of Dapr. But again, if we want to achieve true application portability, it's important, of course. But I'm not sure that many teams encounter this frequently. So that's some of the feedback that developers provide. Okay, to summarize. We see that Dapr gives us the capabilities we need to fully build cloud-native applications in a platform and language-agnostic way. It enables what we've talked about in terms of portability, not only of our application code, but also as we see how we interface with various types of resources or services typically offered by cloud vendors. And by its very nature, you get a separation between code and infrastructure, but to actually make them work well together, you need provisioning schemes that we just saw to support it. And maybe the final point that is important or essential is it's not an all or nothing proposition. You choose the building blocks that make sense for you in your current project. Again, does this say whether you should adopt Dapr or not? Doesn't really, so I'll leave you with a few thoughts. Look into Dapr and specifically should adopt it if a very large part of your business logic will be feasible to be implemented through building blocks alone. Meaning, the extending Dapr things, the dependencies that we saw, if that's something that you know beforehand will not occur too often, and building blocks will support most of your implementation efforts, that's a good signal that Dapr is maybe for you. But if you have sort of an inkling that that's not the case, you will have to extend Dapr, you will have to interface with event stores, you will have to isolate direct SQL queries in separate services, maybe take another stab at whether I should adopt Dapr right now or not. Again, I'm not a fanboy of Dapr, obviously. I want to use it where it makes sense. But that's a good signal, I think. But it also needs to be weighed against the cost of actually managing Dapr. You need to install it in your cluster. You need to upgrade Dapr, etc. You have tools for it that you can use that will help you, but yeah, there's an investment that goes into that as well. And again, provisioning and all of that. But again, I would say that if your application will be realized mostly through Dapr building blocks, and you want to give your developers this transparent experience when it comes to actually interfacing with certain capabilities, yeah, why not explore it? Should you have any questions as you maybe start down that path, do reach out to me. I'm happy to have that conversation. Thank you very much.